Hey guys, back with another lesson, this time on scale drawings and models. So I'm going to start with, you know, when y'all typically ask, when am I going to use this in real life? Well, if you want to be in architecture, architects use scale models all the time when they're designing, especially when things are going to be too big. Civil engineers come in to play when they build bridges or design bridges and buildings. They need to create a model first before they actually do it. And then reading a map. Sometimes GPS fails you and you need to know how to read a map. All right, and then I'm going to help you guys understand just a little bit before we get started what scale actually is. So scale is written as a ratio. So let's take this example right here of 1 to 10. The 1 in our ratio represents like the number in the drawing. So let's say that the 1 is, I'm going to undo this a little bit. So I'm going to say 1 inch. And then ratios can be written with colons, as we know. So 1 inch to 10 feet. So the 1 inch represents 1 inch in the drawing, but then in real life, that 1 inch represents 10 feet. Could be like a model of a house. If you look at a model, 1 inch would represent 10 feet. So this would be 10 feet, this would be 10 feet, 10 feet, and then 10 feet. This is just an example. And then something important too that y'all need to know about today is just keeping your work consistent and uniform. What I mean is if you'll have two different units of measure. So just like we did in measurement conversions, you'll want to keep, let's say your two units are inches and feet, just like I did. You want to keep your inches together and your feet together. And you'll see what I mean when we start practicing together. Okay, so as for the lesson, these first two blanks are scale and then drawing. So a scale drawing is a diagram, map, or model of an object that is too large or too small to draw. The dimensions are proportional to the actual dimensions or distances of the real life example. So some examples of when you'll see this in your real life would be maps, blueprints if you build a house, or floor models. You'll see floor models when you shop around for apartments because you'll want to know like how much am I paying per square foot. And then the key, that's this next blank, on a scale drawing is the ratio of the drawing lengths or its model to its corresponding actual lengths. So corresponding is, remember, same location. And then an example of that, oh yeah, by the way, there's a typo here. We're going to fix this real quick. Put a 1 in front of this 2 right here. And so what it means is 1 inch to 12 feet means 1 inch in the model represents an actual distance of 12 feet. So let's take a look at these two models here. This one, or the scale, this one is a scale. Okay, so I don't know what it's a scale of, but you can see that there's streets and there's some buildings. Oh, it says Chicago Public Library, so it looks like it's a scale of downtown Chicago maybe. And if you look at the key, come back highlighter. If you look at the key right here, it says 1 to 10,000. And then it says 1 inch equals 833 feet. And then this next one over here is a floor model, sorry. And this is a floor model of assuming an apartment. So it says 1 inch equals 12 feet. So every inch that you read on this is 12 feet. So it can kind of give you an idea of the dimensions of the rooms and all that. So the handy tip is that scales are written so that the drawing distance comes first in the ratio. So we're going to practice just finding scale first, and then we're going to move on using scale and finding like a missing measurement or an actual length, or yeah, you'll see. So we're going to find scale. This first example says, inside the Lincoln Memorial, the chamber that features the marble statue of Abraham Lincoln has a height of 60 feet. Suppose a scale model, so scale model is the drawing, of the chamber has a height of 4 inches. What is the scale of the model? So we're going to start with, just like the handy tip says, we're going to start with the drawing distance. So the scale model is the drawing distance. We're going to put 4 inches to 60 feet. And when we do this, we want to simplify our ratio. So I could divide both these numbers by 2. And if I do that, it would be 4 divided by 2 is 2. And then 60 divided by 2 is 30. Both those numbers are even, so I could simplify them again. And I'll write those down. Oops, come back. There we go. So I have 2 inches to 30 feet. And we like our ratios to be as simplified as possible, especially when we have to find a missing measurement later on. It's just easier to multiply with smaller numbers. So anyways, I'm going to divide these numbers again by 2, and I get 1 inch to 15 feet. And that's going to be our final answer. So 1 inch in the scale model represents 15 feet for the Abraham Lincoln statue. And then our next example, Deidre has a room that is 12 feet long. She is drawing a blueprint of her room and has a length of her room as 2 inches. What is the scale of the blueprint? So I see that she has a room that is 12 feet long, and then in her scale, it's going to be 2 inches. So I'm going to set up that ratio. The drawing number goes first. So in this case, 2 inches to 12 feet. And I'm going to see if I can simplify that. Both those numbers are even, so at the very least I could divide them by 2. 2 divided by 2 is 1. So I have 1 inch. 12 divided by 2 is 6. So what that tells me is that 1 inch in Deidre's drawing represents 6 feet in her room. All right, now we're going to actually find distances. So this next example says Jacob has a scale drawing of his yard. The scale of the drawing is 1 centimeter equals 5/10 meter. The length of the patio is 4 5/10 centimeters in the drawing. Find the actual length. So we're going to have to set up a proportion because we have a given ratio, which is that 1 centimeter equals 5/10 centimeters. So that tells me right there that that's a ratio. And I'm going to set up 2 ratios to equal each other, which then becomes a proportion. So I'm going to use my words first because that's what you always do, is words first, then numbers. So I'm going to write centimeters over meters. And then I'm going to write my given information, which is 1 over 0.5 or 5/10. So that's my first ratio, and it's going to equal my second ratio. Now I'm going to take a look. That 4.5 is centimeters, and the numbers for centimeters goes on top. So I'm going to put 4.5 and then x on the bottom. And in this case, all I have to do is cross multiply, because when I do 1 times x, that's just simply x. So I'm just going to multiply my 2 numbers. So I have 4 5/10 times 5/10. And I'm going to take away that 0 because it's not necessary to have when multiplying. So I'm just going to multiply like normal. 5 times 5 is 25, so I have 5 carry the 2. 5 times 4 is 20, plus 2 makes it 22. Now I'm going to count my decimal places, so I have 1 and 1, which makes 2. And so in this case, x equals 2 and 25 hundredths, meters, because that's what I was solving for, was meters. All right, so you can skip this next one right here I'm not going to do it, so y'all don't have to. But we are going to do this third one down here that talks about the distance between Raleigh and Charlotte, North Carolina. So it says the distance between Raleigh and Charlotte, North Carolina is 130 miles. The scale on the map is 1 inch equals 40 miles. What is the scale distance on the map? So I'm going to finish circling all my numbers. And I'm going to use the given information because that's going to help tell me how to set up my proportion. So my first ratio, and remember we got to use our words first. So inches is what comes first. I'm going to do inches over miles. So I'm going to put 1 over 40. That's my first ratio equals, and the 130 is miles. So that means 130 goes on the bottom, and then x goes up top. Now I'm just going to cross multiply. In this case, I will have to divide. So 40 times x is 40x. And then anything times 1 is still that same number. So it's 130. Now I have to divide both sides by 40 because we have to isolate the variable. And by doing so, we have to divide by 30. Or 40, sorry. So I'm going to set up for long division. 130 divided by 40 goes in 0 times. Now if I skip count 40, it goes in sorry guys, oops. Sorry, it goes in 3 times. So I'm going to subtract 120 for a remainder of 0, 1, 0, so 10. I'm going to extend the line for my quotient. Going to add a decimal and a 0, and I'm going to bring that 0 down. So now it is 100. If I skip count my 40s, it goes in 2 times. I'm going to subtract 80 for a remainder of 20. And then if I add another 0, bring that down, it's 200. And it goes in exactly 5 times. So what that tells me is that this scale right here, the scale distance, so x equals 3 and 25 hundredths inches. So 3.25 is our answer. Okay, we're going to do one more. So we're not doing this last one about the sofa. We are going to do this one on a map of Florida. The distance between Coral Springs and Fort Lauderdale is about 4.1 centimeters. The scale of the map is 1 centimeter equals 4 5/10 kilometer. What is the actual distance? So I'm going to use that information from the scale, and that's going to guide me and help me set up my proportion. So I'm going to circle my numbers. I'm going to use my words first. So it's going to be centimeters over kilometers. And using the given information, it's going to be my first ratio of 1 over 4 5/10 equals, now I'm going to look, that 4 1/10 is centimeters. Centimeters goes on top, so I have 4.1 over x. Now I'm going to cross multiply, and in this case, I do not have to divide because 1 times x is just x. So I'm going to use the space off to the side to multiply. I'm going to do 4.1 times 4.5, and I'm just going to multiply like normal. So 1 times 5 is 5. 5 times 4 is 20. I'm going to add a 0. 4 times 1 is 4. And then 4 times 4 is 16. So I'm going to fill in my empty space with a 0 and add like normal. So 5 plus 0 is 5. 0 plus 4 is 4. 2 plus 6 is 8. And then 0 plus 1 is 1. Now I'm going to count my decimal places. I have 1 in the first row, 1 in the second row, which gives me a total of 2. So I'm going to start at the back and go once, twice. So that tells me that x equals 18 and 45 hundredths kilometers. All right. Good job on solving proportions from scale drawings.